and welcome to Caroline's Corner. Today we're going to be learning about nuclear chemistry. I have a very special guest, Dr. Boodle. Please help me welcome her.
Thank you for having me.
No problem. Please take a seat. Why don't we start off with a little bit of background info. Tell our audience a little bit about some of the scientists who were involved in the advancement of nuclear chemistry.
Sure. Henry Becquerel discovered that uranium emitted radiation in 1896. Then Marie Curie discovered that the amount of radiation is proportional to the amount of the element. She also proposed that radiation was a property of atoms. Now my best friend Frederick Soddy, he proposed a theory that radioactivity is the result of a natural change of an isotope of one element into an isotope of a different element in 1902. Pretty cool, huh?
Yeah. Now we're going to open up for audience questions. Does anyone have a question about nuclear chemistry? Yes, you.
What's the difference between a stable and an unstable nucleus?
Very good question. Now you can see on this chart that this is the band of stability. And anything outside is unstable. Now unstable nuclei either have too many protons or too many neutrons. Where a nucleus is on here is determined by the number of protons and the number of neutrons. Most low atomic number nuclei are stable at a proton to neutron ratio of 1. And as atomic number increases, neutron to proton ratio gradually increases.
That was a great question. Do any of our other audience members have another question?
I do.
Yes, go ahead.
What are the types of radiation emitted during nuclear reactions?
Oh, there are 3: alpha, beta, and gamma. Alpha is the emission of an alpha particle containing 2 protons and 2 neutrons. It decreases mass by 4 and decreases atomic number by 2. This is the sign for alpha. Next we have beta. Beta is when a neutron changes into a proton and an electron. The mass does not change, but the atomic number increases by 1. This is a sign for beta. Last we have gamma. Gamma is emission of electromagnetic energy. No particles are emitted. It often happens during alpha or beta radioactive decay. This is a sign for gamma.
We have time for just one more question. Yes.
What are the similarities and differences between nuclear fission and nuclear fusion?
Fission is when the nucleus splits into 2 smaller parts when it is hit by a neutron. Now fusion, on the other hand, is when elements come together to form a larger element. Now both are reactions of 2 or more elements, and they both release large amounts of energy. Does that answer your question?
Yes, thank you.
A big thanks to Dr. Boodle. We'll be right back after this break, brought to you by Charmin Ultra.
For your nuclear reactions in the restroom, choose Charmin. Charmin Ultra, less is more, less is more, less is more. Charmin Ultra, less is more.
And we're back with Caroline's Corner. Our next guest is Dr. Schlowinski, and she's an expert on fission bombs, which is our next topic. Please give her a warm welcome.
Shalom, my dear friends. Thank you for having me.
No problem, take a seat. So, let's discuss the reaction that's involved with fission bombs.
Sure. What's happening is a neutron is hitting uranium-235, which is a nuclear collision, which causes it to split into strontium-90 and xenon-143.
So, what can you use a fission bomb for?
Fission bombs have only been used in warfare. For example, it was a fission bomb which the U.S. used during World War II in Japan that killed 150,000 people instantly, and many others died soon after due to the radiation.
What are some of the pros and cons to using fission bombs?
During World War II, Japan soon surrendered. It was used as an end to the war. It aided the U.S. and saved the lives of U.S. soldiers due to how it is not necessary to have hand-in-hand combat with the fission bomb. However, from Japan's point of view, the bombing was devastating and killed many innocent people. If fission bombs continue to be used in war, they have the potential to cause an all-out nuclear war, which could be World War III.
That's so interesting. Thank you so much for being on the show today, Dr. Schlowinski. And we'll be right back after this break, brought to you by Radio Screen.
When fission bombs happen, which you know they do, use Radio Screen to protect you from that radiation.
Welcome back to our last segment of Caroline's Corner. We're going to be discussing the dangers of using fission bombs and why they should not be used. Fission bombs are a form of mass destruction. They kill hundreds of thousands of people, and people can still die from the radiation after impact. Due to the severity of the bomb, if used in war, it has the potential to start a nuclear war of which there is no escape. We have phone lines available for you to anonymously call and let out your obsessive feelings for fission bombs. If you're experiencing any nuclear war desires at all, please call.
Hello? Sure, Henry Becquerel.
Go on here, just pick one and say it. Jenna, did you bring glasses? Do you have glasses?
No.
Or maybe goggles. Do we have any goggles?
I have glasses in my house.
Is that good?